Hello, everybody. Good morning, good afternoon, good evening. We don't know exactly where you are, but the most important for us is that you are here today with us, with Connor. So thank you so much for being here to join the tour, the AUUC tour. Today I'm very honored to be here as part of Lux OUG team. So Fernando, could you tell us something
Yes.
about?
So it's a pleasure for us to host this day. So we from LuxOG, we are founded in 2019. We have more than 100 members, uh, and our portal is free for membership. So it's luxorg.org. We have more than 100 articles published, and it's a pleasure for us to have Connor virtually here in Luxembourg. So Connor, the stage is yours, and you're welcome in Luxembourg.
Thank you very much. Hello, everyone. Hopefully you can hear me. Hopefully you can see me. It's a big night. It's Friday night. Man, normally I'd be drinking beer, but that's how important I think the Oracle technology community is, that we sacrifice the occasional Friday night. Let me share my screen and we'll get straight into it. What have we got here? Here we go. Let's make that a bit larger. Okay, hopefully you can all see that. Yes, my apologies. I'm from Australia. Like the most of us in Australia, we only speak English. We're far too uncivilized to actually learn different languages. So apologies for all the people who were expecting this to be in their native language. It'll be in my poor rendition of the English language. So let's get into it. Peel SQL. As I said, if I'm prepared to sacrifice a Friday evening, it's got to be for something important, and Peel SQL is what I think is super cool. As said, my name's Connor McDonald. I live in Perth, which is here in Australia. I would love to invite you out, but all of our borders are currently closed, and the talk is they'll be closed until 2021. So virtually getting together is probably the best we can do for a while. As a result, if you ever want to get in touch with me, please, I love talking tech. You can get me on Twitter. In fact, I'll probably use most of our 45 minutes. So if you have questions afterwards, just reach out to me on Twitter. Love to connect. I love talking technology. I have a blog. I have a YouTube channel. Feel free to reach out to me in any of those ways. This is what I do most of the day. I look after the asktom.oracle.com website. And once again, if you have questions about anything, and Peel SQL in particular, please jump on there and have a search and ask some questions. Chris Sachs and I will be happy to help. I'll put this slide up there, not that we don't know anything about it, obviously, but I always put this slide up in some of my recent talks just to reinforce that if we're going to have a great community, well, we need people in the community. We need them healthy and happy and alive, no matter what their situation. So please, I always say this to wherever I'm talking in the world, follow your local guidelines, your local laws. Eventually one day we will meet again in person, and it would be an absolute tragedy if some of us didn't get to make that opportunity because of COVID. Now, before we begin, I want to lay down some ground rules. This is not about some sort of religious war. And one of the I think the downsides of Peel SQL over the years has been is some people have been saying that, if you're not using Peel SQL everywhere, then you should be cast out of the Oracle community. I don't care about what your views on Peel SQL are. I care about what I think most of us care about, which is successful applications. And my definition of what a successful application is it meets the business objectives. It's very easy to get caught up in, we should be using this language or this technology or this new cool thing. But really, as IT people, our job is to meet people's business objectives. The other thing is meeting performance objectives. It doesn't matter if my application does exactly what my business wants if it takes 10 minutes to conduct a transaction. So that's really a business objective as well, you could argue. A language needs to meet your development objectives. Same thing. If I can build a fantastic application, that's great. But if it takes me 10 years to build it, that's not so good for my business either. And finally, and probably most importantly nowadays, it's got to meet the security objectives, because nowadays security is certainly at the forefront of all modern IT. It's the thing that, there are so many things in terms of social media, etc., where what's the term? Fake news. Yeah, if you get hacked, you're out of business. So let's be real here. Ultimately, this is all about one thing and one thing only. It's about money. Your company exists really to have a revenue stream, to make money. And the objective of successful applications is to make your company more money. Make more, spend less. And Pure SQL, in my view, should help you achieve this. If it doesn't, then obviously you shouldn't be using it, just like any other language. You should be choosing technology that basically makes your company successful. Now, I thought I'd share with you perhaps the original motivation for Pure SQL. And that was Pure SQL really was a facility about improving performance of applications in the client server world. And rather than dwell on the past in terms of technical, I thought we'd have a little bit of fun here, and we'd dwell on the past in terms of what we used to do in real life, or what we could do in real life, and how it reflects on Pure SQL. I get out of bed in the morning, get myself some breakfast bowl, lob in a bit of cereal, add a little bit of milk, and there's my breakfast done. Obviously, that's not particularly satisfying, so what would I do next? I'd grab the milk out of the fridge again, a little bit of cereal, add a touch of milk, and my next little bit, and so on, and so on, and so on. It seems like I missed on that one. I have to try again. And we keep on going. It seems like that, no one would do that. Like, that's just, ridiculous. That was just a little bit of fun I had in terms of making a video. And of course, when I show people these videos and I say, that's often how people approach their technology. They say, we would never do that. That's stupid. No one eats their breakfast like that, which is true. But the sad fact is so many people do, and they did back in the client server world. And somehow they think the evolution of technology has resolved them of that responsibility. Is that people say, it's okay nowadays, we don't use client server, that's antiquated, that's sort of an antiquated paradigm. We have an app server now, it's close to the database. But it doesn't matter what platform you're using. I don't care if you're using Python or Java or Node or insert any cool language nowadays here. And it doesn't matter what direction you're passing data. If your data is going into the database or going out of the database, the sad thing is no one does this anymore. No one passes data like that to the database. They do it like this. They have these very, very chatty, busy applications, and it kills them. And the sad thing is, you look at your average database server nowadays, it's insanely powerful. You look at your average application server nowadays, it's ridiculously powerful as well. It doesn't matter how fast and powerful they are if you're spending all your time bouncing back and forth between them. It leads to this kind of thing. Oh, the database is slow. That's, my application code is fine. The database must be. So we need to move to a new database platform. It's amazing how much justification is done in terms of migrating to newer technologies just because we didn't understand the basic premise between building great applications. So I thought I'd spend the rest of this time talking about Pure SQL, as I said, has its origins back in a client server days. Is it still a solution for modern applications? And the way we focus on that is, remember what the definitions of success are. This is not a religious debate. It's performance, maintenance, security. Performance, maintenance, security, development, etc. These are the things that are critical in terms of building great applications. Where does Pure SQL fit in there? My job is to see if I can convince you of why I think it's relevant for those particular perspectives. Now, a small digression first. You may have read that there's this, what I call utopia, the perfect Pure SQL implementation. You may have seen one of these slides in the past. It's incredibly detailed, incredibly sophisticated, incredibly complex. It's known as SmartDB. And you can read about it in depth at this link, and you'll get these slides after the session, obviously. And that's great, but don't forget utopia, the perfect solution. It says here, a place or state with everything is perfect. The real definition of utopia is not that. The real definition of this, it's an imagined place. And don't get me wrong, SmartDB is a wonderful approach to building an application. But I want to be realistic here. As I said, this is not a religious debate. The number of people using SmartDB in its entirety around the world is generally fairly low. And the sad thing is, I've seen people out there in the community saying, well, because of that, if you're not using SmartDB, you're a failure. And that's not correct. Similarly, I see people out there who have actually embraced a lot of the philosophies of SmartDB, but they're just a little bit short. They've done most of it, but not all of it. And same thing, some people in the community go, oh, that means you're a failure. That's not true either. Let's forget about philosophical arguments. Let's just focus on building successful applications. And for that, maybe even just a small PL SQL investment is going to help you. And that's maybe all you'll need. You don't, if you want to embrace PL SQL across the board, that's great, but you don't have to. And you're not a failure if you don't. So let's start with performance first. If you're evolving to PL SQL, the first thing is getting past that first fear. If you're trying to convince your developers who are maybe Java or JavaScript, etc., to maybe look at PL SQL as well, the first fear is, well, that's another hop, that's another layer. And this is the first fear because often people will do this benchmark or this demo as a way of saying, yeah, PL SQL, it's just an extra step. It's going to add to the cost of building applications. So here's a very, very simple app. It's just a primary key lookup, and this one's written in Java. That's all it is. So that's an application with no PL SQL. It just does a single query straight there in the Java program. What if I said to you, to my development team, I'd like you to move the SQL into a PL SQL call and then have your Java program just call that. That's the argument here. So let's test that out. This is the argument that often makes PL SQL break down in terms of people say, I don't want to use PL SQL. So let's start with this very, very simple argument. So let's do a little demo here. Here's my simple primary key lookup, and all it's doing is all the code in Java. It's doing 20,000 iterations of that simple primary key lookup. It took about 2.7 seconds and used 42 centiseconds or 0.4 of a second of database CPU time. Now let's take that same SQL, move it into a PL SQL program. So this is the same routine now calling PL SQL to do the exact same SQL statement. And we run it, very simple. And notice, well, it takes a bit longer. It's about 10% longer. It used more database CPU. And that's what happens when you show these very simple demos to people. PL SQL, it's more expensive. I knew it'd be more expensive because there's more layers. It's not Java to the database, it's Java to PL SQL. And then that code has to be compiled by the database, and the database uses more CPU. And everyone gets their knickers in a knot saying PL SQL is a bad idea. There's a certain irony when people say, because there were more layers, that things are worse. Because if you say more layers are more expensive, you got to wonder, how do we get from this place, which is how we used to build applications, Java talking to the database, to this place where Java talks to, a microservice talks to something else, which talks to an orchestrator, which talks to something else, which talks to this, which talks to Java, which talks to this, etc. It's funny how no one sort of believes the fact that over the years we've added so many more layers, and yet we say that's the right way to go. But you ask someone to add one more to do PL SQL, and they're like, no, layers is bad. That's because it's an artificial example. I don't know about you, but I don't know of any applications out there that do primary key lookups all their life. Let's make it a little bit more realistic. Let's turn my application into a simple API. In this case, I'm doing 3 queries, and the specifics don't really matter. This one is querying a customer, querying some orders, and querying some order items. So give me a customer's details. For that customer, get their orders. For that order, get their order items. Let's now do that in the same way. One in Java, one as a PL SQL routine that the Java program calls. Now we're making it a little bit more realistic. So Java simple API. So this one's doing all the SQL in Java. Create my tables. I think it's doing another set of iterations. It's chugging away. This time, so 6.8 seconds, 195 centiseconds of database CPU. This is a busier, a much more realistic application. Let's now do the exact same amount of work using a PL SQL call. Chugs away. Here's where we start to get a more realistic idea of the benefits of PL SQL. Both these programs are doing the exact same functionality. The PL SQL one now is approximately twice as fast. Now, that's because I'm doing less jumping back and forth to the database. There's a time you lose in simply navigating back and forth to the database. But here's the more interesting thing. notice that even though I called a PL SQL routine, which is something that is running in the database, it's code that's running in the database in addition to the SQL statements, we actually used less database CPU. We went from 195 centiseconds down to 109. The more PL SQL you use, the less database server CPU you burn. And let's not beat around the bush here. What is database CPU? It's money. On the cloud or on premise, effectively, when you burn CPU, that's what you'll pay for your licensing. So I can't stress enough, using PL SQL once you start getting to real application code actually saves you performance time, which is obviously important from a developer perspective, but it actually saves you physical resources. It saves you money on your database server. Now, you may be arguing, well, that's still just a little simple API. Let's make it as real as we can. This is an application written by Dominic Giles called SwingBench. It's a benchmarking tool written in Java to actually do a genuine application code. You can, create customers. You can choose different benchmarks. This one we're going to do now is called the order entry benchmark, but it is a genuine application. It can run in GUI mode like you can see here, but because we're on Zoom, I'll run it in character mode because we're not going to smash our networks. So let's run this thing for real. The great thing with SwingBench is you can run the same benchmark 100% Java or 100% PL SQL being called from Java. So let's run the client version first. This is all the code running in Java. And all you really have to keep an eye on is the TPS column at the right. That's the transactions per second. I'll let that chug away for a little while. And what do we got? So it's 319. It's sort of ramping its way up, 331, 305. So it seems to have hit roughly its point now. So if I hit return, it'll finish and I'll get an average. Average transactions per second, about 300 per second. Don't get me wrong, this is just single threaded performance. That's still very, very impressive. Let's now do it where I'm doing the exact same benchmark, but all the calls are being done on the server in PL SQL. And this is a genuine, real application that gets probably the closest we can get to a genuine measure of the benefits of calling PL SQL routines as opposed to calling SQL direct from the application. This guy's chugging away as well. So we had 301 when we're doing all the work in Java. I'll let it go a bit longer. That looks good enough. And we kill it off. And we can see we've gone to 350. That's probably a realistic idea of the benefits you'll get simply by moving the calls to PL SQL. About a 15% performance benefit and use less database server resources. And don't get me wrong, that SwingBench app that John wrote is a beautiful app. It's about the best Java can do. Now, I said it's all the difference between jumping back and forth between the network. It's not just about latency, and we'll come back to why shortly. So hopefully that covers off the performance perspective. Let's now talk about the development benefits of using PL SQL. And for me, when you're doing development, there's obviously the building phase when you build whatever your applications you're running, and then there's the ongoing maintenance. Let's talk about building first. The first benefit is PL SQL crashes early. Now, that's a quote from a book called The Pragmatic Programmer, where what happens is, a dead program does a lot less damage than a crippled one. It's much better to have an application die than to be running incorrectly. And the problem with programs that don't natively have an interface to Java, to SQL, is, as you can see here, you can put any old piece of string into a Java program and it'll compile fine. It's only when you run it that it'll crash, saying that's obviously not a valid piece of SQL. PL SQL is different. PL SQL is when you put SQL in there, it's compiled right there and then. You know at compile time whether your program is actually going to have a chance of working. As a developer, you get quicker feedback as to whether your SQL is valid. The second benefit is the lazy way is the best way. And let me explain what I mean by that. And let's not use the term lazy, because as developers, we take pride in our work. Let's call it the efficient way. This is the easiest way to write a SQL statement in Java. I simply concatenate what I want to do in SQL in strings. If I have an employee number that's been passed in by a user, I just concatenate to my query and run it. This is the proper way to do it. You prepare the statement, you do some binding, you set the variables, then you execute it and go. Now let's face it, developers, when presented with 5 lines of code versus 10 lines of code, are going to go with 5 lines of code. The problem is, if you build SQL by concatenation, you're going to get hacked for sure, because if your code in Java looks like this, you're expecting someone to pass in just an employee number like 6543. But someone malicious might pass in something like this in green, which is and 1 equals 0 to eliminate the top half, and then they go looking in your database dictionary for key tables. If they find one called security, this will be the next parameter they pass in. They start looking for usernames. Building SQL by concatenation opens you up to SQL injection. Let's look at the Peel SQL equivalent. This is the easiest way to write SQL in Peel SQL. And it's optimal. It's not built by strings. It can't be hacked. It automatically uses bind variables. If you want to build a SQL statement with strings in Peel SQL, it's hard work. You have to do a lot of coding, so no one's going to do that. The lazy way is actually the secure and safe way in Peel SQL. Don't get me wrong, in later versions of Peel SQL, we made it easier to dynamically build SQL. I think that's a mistake. I hate that. I would much rather it be hard to build dynamic SQL strings in Peel SQL. People say, that's okay. We have an ORM. It sits over our Java layer. Therefore, we are immune to being hacked because the ORM takes care of all the building the SQL for you. I got news for you. There's plenty of ORMs out there that, they're just programs as well. So even your ORM may be found to be vulnerable. Much better to use Peel SQL, where it's almost impossible unless you go out of your way to build SQL statements that can be injected. This is not just a static versus dynamic discussion. If we go back to performance, if I have a SQL statement that I then put into Peel SQL, when I run it, throughout the lifetime of my session, it'll be parsed once, even if I do lots and lots of executions. So I parse this once, even though I ran it, how many times? 10,000 times. And also I got the benefit of every time I did a fetch, you can see 10,000 fetches, but over at the right, I got 40,000 rows. So we automatically do array fetching as well. So we get automatic bind variables, automatic parsing reduction, and automatic array fetching. Hence, it's very, very fast. And I didn't have to do anything. I didn't have to write any code. It just did it for me. If I do the same thing in Java, the simple code here, preparing a statement and then looping through it, gets me this. By default, I do 10,000 parsers. They're soft parsers, but they're 10,000 parsers. Every time I do a fetch, 40,000 fetches gets me 40,000 rows. I didn't have any array fetching benefits in there. And as a result, it burns more database CPU. Now, don't get me wrong. All the things that Peel SQL does, you can achieve in other platforms. I just have to add this code in, for example, for Java to make sure I'm doing prefetching, to make array fetching, to make sure I'm doing statement casing, etc. But it's all more code and therefore often gets overlooked. As I said before, our swing bench demo did 300 transactions per second, even in pure Java. And people say that's good enough for me. And that's totally fine if you're going to say that. But it also perhaps labels you sometimes as a little bit of a hypocrite, because I've had people say to me, I don't need Peel SQL because the performance is fine. And on the same token, they say, but that's why we need to go microservices. And that's why we need to have all these different, sharded platforms, etc., so we can achieve the scalability we require. There's a very good chance to achieve the scalability you require. You just need to use Peel SQL and not worry about all this complexity. The next benefit in development is that no application, in my view, is 100% complete. If you build a massive application in Java or Node, etc., it probably does all the things the application needs to do, except perhaps some boundary cases like the initial data load or maybe data patching. If you've got those kind of code elements running in Peel SQL in the database, then other things outside the application, maybe an ad hoc query or some archival, can take advantage of those Peel SQL functions you've written. You can't do that without writing in Java, for example, without writing more code. Having it in Peel SQL means it's accessible by not just the application, but by other ad hoc requirements as they come up. Now, a common build criticism when it comes to Peel SQL in development is that you don't have a private sandbox. Most developers like to build in isolation. They have their own Java runtime environments, their own private app servers, etc. And that was true. I'll happily concede that in the past. But nowadays, let's face it, anyone on the planet can get themselves a free working Oracle database. It's free and free forever. Similarly, even if you're running database on premises, you can get a pluggable database, drag that out of your central development database and put it onto your own laptop. Now you might be thinking, well, that's going to cost me a license fee, isn't it? Well, it's not. It's not going to cost you a single cent, because you can have up to 3 pluggables on a development server or production server, in fact, on any server in 19C for no license cost. And you can have Oracle XC on every single developer's laptop, similarly for no license cost. It's 100% free. So put 3 pluggables on your development server, let people grab those pluggables, plug them into their Oracle XC installation on their own laptop. Every developer now has their own private sandbox of a database to build their PL/SQL assets on. And that's all 100% free. So hopefully that addresses some of the fears and concerns about the build element of development. Let's talk about maintenance. The first benefit is what I call free dependency analysis. There's a table called DBA dependencies, all dependencies, user dependencies, etc. And it actually tracks all the cross dependencies between objects in the Oracle database. If I have a procedure called my procedure, which references the scott.emp table, then I look at DBA dependencies and it tells me that procedure, in order to run and to live in this database, depends on the emp table and depends on the core PL/SQL language package called standard. That's always there. It's maintained for me. If I had that something, for example, in Java, I would never know. If I drop the employee table, my Java programs just crash. I don't know. Now, a common maintenance criticism is that if you want to deploy PL/SQL, that means you have to take your application down. There are ways of avoiding this, and the first one is packages. They break what I call the invalidation chain. If you're not using packages, if you build all standalone procedures in PL/SQL, and procedure A calls B, and B calls C, and C calls D, if you change D, then yes, everything up the line is broken until recompiled, either manually or automatically by the database. However, if you do it in packages, then we split the package into specification and body. Now, if you change the body on package D, nothing changes. Everything else stays fine. Because all the other things, package A, B, and C, only refer to the specification. In 11G and beyond, you can even change this package spec. As long as you add to the bottom of the specification and leave the rest alone, then even then, you don't break that invalidation chain. My general rule is no single production piece of PL/SQL code should ever be deployed unless it's sitting inside a package. In 12C and beyond, you have what we call addition-based redefinition. That takes that whole process one step further. You can actually have multiple versions of the same program running at the same time in production. I could have, for example, my procedure version 1 running, and some people are running that. I could actually deploy version 2 in isolation. No one can even see it. And then I can switch people over to actually silently switch over to using version 2. A lot of people say don't use addition-based redefinition for the same reason about this utopia with SmartDB. They get told if you're going to use EBR, you have to change all your tables, all your views, all your assets, whatever. Forget about the utopian business. We don't have to worry about that. It might be enough for your organization to only use EBR just for PL/SQL deployment so that you can roll out PL/SQL code in a version fashion. If you have to change tables, maybe you don't do that. Maybe you take an outage for that. But if you just want to use PL/SQL in a version manner, that's totally fine as well. Let's talk about security. Benefit number one of security is PL/SQL in itself is not an improvement on security. The only thing it gives you out of the box really is the fact that by default, any static SQL in PL/SQL is going to be automatically bound. You're never going to get let's try that again. You're never going to get a SQL injection risk with static SQL. But if you do embrace PL/SQL, it opens up opportunities for more security. Because often when I see customer sites, when I go visit them, this is like the most heartbreaking thing I see. You log onto their database, you look at VDollar session, and they have all these Java connections, and they're all connected as my schema being the actual user that owns all the objects in the database. They have all the connections coming in just as the schema owner. That is a nightmare because, as we said, you can put any piece of SQL into a Java program just as a string. And if you're connecting as the schema owner, well, I could put drop table in there. I could put drop anything in there. I could put truncates, etc. It's a massive security hole and exposure to let people connect as the schema that owns the objects. Now, there isn't a limit on the number of schemas you can have in an Oracle database. You can have tens of thousands if you like. So I always prefer least privilege being best privilege. Nothing should ever connect to the database to any account that owns objects. So at your very barest minimum, this is the kind of security model that people should embrace. Ideally, we go further, but this is the barest minimum. You have my schema, which owns all the objects, and then you have some other schema, which will do the connections, and it will have sufficient privileges to run your application. And out of the box, a lot of people, this is a very common approach. I don't think it's great, but it's so much better than connecting as the schema owner. So you may have an app connecting schema, which has insert, update, delete, select privileges, whatever. But this is where I'd like people to get to. This is the ideal. And this is why I say PL SQL gives the opportunity of better security. If I go back to this previous one, the moment I give someone insert, update, delete, insert, etc. privileges, once again, rogue code in, say, the Java layer allows people to do a delete. And when I say rogue, it doesn't mean it has to be malicious. It could simply be an accidental, for example, delete that forgot to build the where clause properly. Suddenly you've wiped out all your transactions. If I do it in here where all the SQL in PL SQL is static, then now the connecting schema doesn't actually have all those destructive privs anymore. All it can do is run PL SQL programs. That's a way of hardening up the security of your application. Now, that's a big undertaking. If the application connecting can only ever run PL SQL programs, that's a fairly large undertaking. But even this is a good compromise, where all the destructive stuff is done with PL SQL. Insert, update, delete. All the queries are done just with select privileges by your app connecting schema. Even that compromise is a reasonable one. That's all I'm going to say on security, because if you really want to know how to do security properly, you should stay online, because coming up after me is Flora with a fantastic talk on securing your database assets. But hopefully you can see how PL SQL plays a part in that improved security. Benefit number 2 is really a corollary of if you can have your applications only calling PL SQL routines in something like this, where the app connection does all its interactions through PL SQL, you'll never need a database trigger. Because if already in the database is all the logic that is doing the control, the data manipulation logic that the application requires, anything that a trigger would normally do would actually just be put into your PL SQL programs. And the reason that's a benefit is triggers are hard to get right. They're easy to code, but they're hard to get right when it comes to the appropriate locking and concurrency needs. So if you don't have the triggers, that can be a benefit. Now, let's put all that theory into practice. And what I mean by that is, so far I've given you some demos, but all of it is just me really talking. Let me give you a real customer example. And that customer is the place I worked before I joined Oracle back in 2015. The place I worked was a betting organization here in Western Australia. And don't get me wrong, Australians love to gamble. We do a lot of gambling, and we bet mainly on horse racing, sport as well, but mainly on horse racing. This customer, for example, on given certain times of the year, is taking $10 million a minute in terms of liability from their application. What I mean by that is if they lost their server during certain times of the year, they would lose $10 million a minute in revenue while the server was down. So it was a very, very mission critical application. It was running rack and clustering, etc. And performance obviously was paramount. Now, the development team for the application that running this system was all written in C++ and C#, and the team had no Oracle experience. In fact, they had no database experience. They had been employed because of their C# and C++ skills. The system they were building was to be built in C++ and C#, but no one sort of clicked to the fact that if you're dealing with a database, you probably need some database expertise as well. So the whole system architecture was C#, C++, a service bus, Oracle Tuxedo, all going through WebLogic. That's sort of a picture of how it was meant to look, but this is how it was working. lots of SQL code way up in the application tier and no real appropriate bundling of code. And they reached out to us and said, hey, Oracle, the database is slow. It wasn't slow. They were just using it in an inappropriate way. Lots of very, very chatty application, and they simply couldn't do the transactions per second that they required on critical times of the year. And millions of dollars are at risk here. As you can imagine, if you're running a betting organization, you have a lot of APIs. You have when a race starts, when a horse joins a race, when a horse gets taken out of a race, when a new customer signs up, when someone makes a deposit, all the normal things that you would do if you were doing a gambling organization. They had a little API written in C# or C++ for everything. Now, when they reached us and said, we need some help in terms of database performance, do you think we said to them, you know what? You need to take all those hundreds of APIs and rewrite them in Pure SQL because that's what we told you to do? No, that's ridiculous. We took two. We started off with literally two of their routines and moved them into Pure SQL. The two most high performance, high demand, high frequency routines they had. And as you can imagine, they are a customer placing a bet. That's what comes in. And someone saying, have I won? Because the way gambling works is you bet on a sporting event or you bet on a horse race. And then when it's finished, you present your ticket and say, is this the winner? It's like doing the lottery. They're the only two routines we moved into Pure SQL, and that solved all their performance problems because that was 80% of the work of their application. That was it. And that's the thing I want to stress on this meeting today is it's not a question of if you have an existing application, you should dump it and rewrite in Pure SQL. That's ridiculous. Now, don't get me wrong, the benefits can be very, very, very addictive. Once they saw the benefits, this is how their application looked on day one, once we'd moved some of it into Pure SQL. It was still mainly C#, a little bit of Pure SQL. When I came back a little bit later, it was about half and half. A little bit later on, more and more got moved to Pure SQL, more and more C#, just calling Pure SQL routines. In fact, on office hours last year, someone made a quote. One of the customers of Oracle said, we added one procedure to solve a problem, then another one to solve another problem, and very quickly, our customers want Pure SQL everywhere. It is very, very addictive. So let me address finally some of the common criticisms of Pure SQL. People say, well, Pure SQL is not object-oriented. Every modern language nowadays, JavaScript, Java, Node, they're all object-oriented languages, but Pure SQL is not, so it's not cool. But what are the principles behind object-oriented language? The principles are you have attributes and artifacts and you wrap them, you encapsulate them in objects and expose methods. That's the concept mainly behind object-oriented programming. But Pure SQL is simply the same thing. It is an encapsulation layer around your database and your data artifacts. So yes, it's a procedural language syntax, but the philosophy of Pure SQL is identical to object-oriented languages. That is, you protect important assets and attributes with an encapsulation and expose it via methods. The next criticism is we don't have Pure SQL skills. Let's face it, the modern developer coming out of an undergraduate course nowadays is probably well-versed in JavaScript, Java, C#, etc., less so in Pure SQL. It's a procedural language, and realistically, I know this sounds a bit brutal, but if you can't pick up Pure SQL in like a couple of days, then maybe programming is not for you because it is literally about the most banal language I could think of. It is just the normal stuff that all languages have. It has subroutines, it has if, then, else, it has operations, etc. There's no polymorphism, there's no abstractions, etc. It's a very, very basic, simple language to learn because that's all that's required of it to interact with the database. People say, well, we struggle with SQL and therefore we're going to struggle to write good Pure SQL as well. And even if that is the case, it doesn't really matter. Pure SQL might just be all that's required for your application to simply grab existing SQL and stick it into the database. If that's the only thing you do with Pure SQL, you'll still see huge benefits. Remember, this is not about trying to achieve some perfect utopia. If your developer task force is expert in Pure SQL, then yeah, head down that way. You'll get the maximum possible benefits of a Pure SQL based architecture. But if your developers aren't, don't think you can't get some benefits. You can get enormous benefits from security and performance just by moving a little bit of PL SQL. That's all you have to do. So I've got 5 minutes left. Let me wrap it up here. It doesn't have to be a war. That's the overriding message here. It's not, I'm in the PL SQL camp and you're in the Java camp and we'll fight it out. It's ridiculous. It is about choosing the technologies to get the benefits for your business and your customers. And often that is just grabbing some of your application and moving it into PL SQL to make it perform better, make it more secure, to get better dependency analysis, and just use less database resources to save your company money. It doesn't have to be utopia. It can be if you have the right people and you have the right skill set. You can achieve mind-boggling things with PL SQL as the core of your system architecture. The perfect example is Apex, Application Express, is almost a 100% PL SQL driven metaphor. But PL SQL, I stress, is easy to learn. It's easy to write, especially in the early days where you're just doing small, simple routines. And you might be thinking, well, that's fine, but what about the future of PL SQL? Don't get me wrong, PL SQL is 40 years old, but it doesn't mean we don't continue to innovate it. If you go to this link here, bit.ly PL SQL 20C new features, yes, even in 20C and 21C, we are continuing to add more and more power into PL SQL. There's actually a lot of stuff in there, and it continues to be a high focus point inside the Oracle organization. As I said, you'll get great wins for just a small amount of effort. All it takes is those small wins, and your customers themselves will be reaching out to you going, hey, let's move some more stuff into PL SQL because it runs better. It's quicker to develop. It just needs some little baby steps. And even if you're a non-PL SQL person, those little baby steps are going to kickstart you to being a much more accomplished Oracle database technologist. This is my son, Max. He's, I got him started very, very early. So yeah, he's going to be a very good PL SQL programmer when he grows up. Just a little bit of fun there. Thank you very much for your time. I got 3 minutes left, so we can take some questions if you like, but I will say, hopefully you enjoyed this talk. I'll be back on the OGB EMEA tour on Monday as well. So make sure you stay throughout hopefully the rest of today to watch Flora and the rest of the talk. Jeff Smith's coming up as well, but also for the rest of the days as well. I'll either be there as a speaker or I'll definitely be there as an attendee. So it'll be great to catch up with you. Thank you very much for your time. If you have any questions, throw them out now, but otherwise just hit me up on Twitter and we can answer questions there as well. I'll stop my share and let our organizers take over.
Hi, Connor. Thank you so much for your presentation. Let's see if we have some questions. No, people in the audience are too shy to raise questions. I don't know why, but we got no questions so far.
No.
That's totally fine. Yeah, as I said, my Twitter is just search for me on Twitter, and I'd love to reach out and connect. And yeah, follow me on Twitter, and I'll do as much PL SQL stuff as I can in the future. But yeah, as I said, stay on. Make sure you see Flora's talk, because in terms of security, that's the big thing nowadays in the world. So yeah, stay on for Flora's talk, and I'll be attending that shortly.
Yeah, me too. So let me check. Okay, there is some in the chat. No, Dimitri, it's thank you. Thank you very much for our presentation. But no questions. Yeah, let me check again.
Thanks everyone, and don't forget as you can see, this is being recorded as well, so you get the recording. I'll send the slides over to the organizers, so you'll get them as well, and you can digest it perhaps a little bit more slowly than the 45 minutes.
Yes, Connor, and thank you for coming to Luxembourg virtually, and we hope that next year we are together here in Luxembourg.
I hope so too. I'd love to be there.
Thank you, Connor.
Thank you.
Thanks
Bye-bye.
everyone. Have a great night.
Thank you. Bye-bye.